Hey there, space explorers, and welcome back to another incredible journey through the cosmos. I am so excited that you decided to click on this video today because we are about to embark on one of the most fascinating adventures you can possibly imagine. We are going to travel billions and billions of miles across the vast emptiness of space to visit every single planet in our solar system. And trust me when I say this, by the end of this video, you are going to see our cosmic neighborhood in a completely different way. Before we blast off on this epic voyage, I need you to do something really important for me. See that little subscribe button right below this video? Go ahead and smash it right now. And while you're at it, hit that bell icon so you never miss another amazing video like this one. Also, drop a like on this video because it really helps the channel grow and allows me to keep creating content like this for you. Now, here's something fun I want you to do. In the comments section below, tell me where you are watching this video from and what time it is where you are. I absolutely love reading your comments and seeing how our community spans across the entire globe. Whether you're watching this from a cozy bedroom in Tokyo at midnight, or maybe you're on your lunch break in London, or perhaps you're relaxing on a Sunday morning in Los Angeles, I want to know. It is incredible to think that people from all over our beautiful planet Earth are watching the same video about the planets that share our solar neighborhood. So, drop that comment right now and let us build this amazing global community together. All right, now that we've got all of that sorted, let us begin our journey. Picture yourself floating in the inky blackness of space. Stars twinkle all around you like diamonds scattered on black velvet. And there, in the distance, you see it, our sun, a massive ball of burning hydrogen and helium, so big that you could fit over 1 million Earths inside of it. The sun is the gravitational anchor of our entire solar system, and everything, I mean everything, orbits around it. 8 major planets, 5 officially recognized dwarf planets, countless moons, asteroids, comets, and all sorts of space rocks and debris. All of them are held in an eternal dance around our star by its immense gravitational pull. Now, the planets in our solar system are not all the same. They come in different sizes, different compositions, and different characteristics. We have what scientists call terrestrial planets, which are the rocky worlds closer to the sun. These are Mercury, Venus, Earth, and Mars. Then we have the gas giants and ice giants further out. Jupiter and Saturn are the gas giants, massive balls of hydrogen and helium with no solid surface to stand on. And then Uranus and Neptune are the ice giants, similar to gas giants but with more icy materials in their composition. Today, we are going to visit each and every one of these worlds, starting from the closest to the sun and working our way out to the frozen outer reaches of our solar system. So, strap yourself in because our first destination is the smallest and fastest planet in our solar system. We are heading to Mercury. Mercury is the closest planet to the sun, orbiting at an average distance of about 58 million kilometers, or roughly 35 million miles. Now, if you think that sounds close, you are absolutely right. Mercury is so close to the sun that it completes one full orbit in just 88 Earth days. That means 1 year on Mercury is less than 3 months here on Earth. Imagine having your birthday 4 times every Earth year. You'd be stacking up those birthday cakes pretty quickly. But here's where things get really weird and fascinating about Mercury. Even though it races around the sun incredibly fast, Mercury rotates on its own axis very, very slowly. It takes 59 Earth days for Mercury to complete one rotation. This creates one of the strangest situations in our solar system. Because of this unusual combination of fast orbit and slow rotation, if you were standing on the surface of Mercury, you would experience something truly mind-bending. From one sunrise to the next sunrise, 176 Earth days would pass. That's right, a single day on Mercury, from sunrise to sunrise, is actually twice as long as its year. So, while Mercury zooms around the sun twice, the sun would only appear to rise once from your vantage point on the surface. Wrap your head around that one. Mercury is also the smallest planet in our entire solar system. With a diameter of only about 4,880 kilometers, it is barely bigger than our own moon. In fact, Two moons in our solar system, Ganymede, which orbits Jupiter, and Titan, which orbits Saturn, are actually larger than Mercury. But do not let its small size fool you. Mercury is an incredibly dense little world. It has a massive iron core that makes up about 85% of its radius. This gives Mercury the second highest density of any planet in our solar system, right after Earth. The surface of Mercury is absolutely battered and cratered. It looks remarkably similar to our moon with its gray, rocky landscape pockmarked by countless impact craters. This is because Mercury has virtually no atmosphere to speak of. What little atmosphere it has is so thin that scientists call it an exosphere. It is essentially indistinguishable from the vacuum of space. Without an atmosphere, there's nothing to burn up incoming meteoroids, so they slam directly into the surface, creating craters of all sizes. There is also no weather, no wind, no erosion to smooth out these craters over time, so the scars from impacts billions of years ago are still visible today, frozen in time on Mercury's ancient surface. The lack of atmosphere also means Mercury experiences some of the most extreme temperature swings in the entire solar system. During the long Mercurian day, when the sun beats down on the surface, temperatures can soar to over 420 degrees Celsius. That is hot enough to melt lead, zinc, and tin. But when night falls on Mercury, and remember that night can last for a very long time, temperatures plummet to negative 170 degrees Celsius. That is a temperature swing of nearly 600 degrees between day and night. No other planet in our solar system experiences anything close to that kind of temperature variation. One of the most striking features on Mercury is a massive impact basin called the Caloris Basin. This enormous crater is about 1,550 kilometers across, and it was created by a massive asteroid impact early in the solar system's history. The impact was so powerful that it sent shockwaves through the entire planet, creating a region of chaotic terrain on the exact opposite side of Mercury. Scientists believe the seismic waves from the impact traveled through Mercury, converged on the opposite side, and jumbled up the landscape there. Mercury also has something called scarps, which are basically huge cliffs that run across the surface. These scarps, some of which extend for hundreds of kilometers and rise up to 3 kilometers high, were formed as Mercury's interior cooled and contracted over billions of years. As the planet shrank, the surface wrinkled and cracked, creating these impressive cliff systems that snake across the landscape. Despite being so close to the Sun, Mercury is not actually the hottest planet in our solar system. That honor goes to our next destination, because while Mercury may be closest to the Sun, another planet has something that traps heat far more effectively than simple proximity ever could. So let us now leave the cratered surface of Mercury behind and travel a bit further from the Sun to visit a world that has been called Earth's twin, but in reality could not be more different from our home. We are heading to Venus. Venus is the second planet from the Sun, orbiting at an average distance of about 108 million kilometers, or roughly 67 million miles. It is almost exactly the same size as Earth, with a diameter of about 12,100 kilometers compared to Earth's 12,756 kilometers. Venus has about 80% of Earth's mass. Looking at these numbers, you might think Venus and Earth are practically identical. But oh, how wrong that assumption would be. Venus has earned some rather dramatic nicknames over the years. It has been called Earth's evil twin and the planet of doom. And honestly, those names are pretty well deserved. You see, Venus is wrapped in a thick, dense atmosphere that is absolutely nothing like the air we breathe here on Earth. The Venusian atmosphere is about 96% carbon dioxide, and the atmospheric pressure at the surface is a crushing 92 times greater than Earth's atmospheric pressure at sea level. Standing on the surface of Venus would feel like being nearly a kilometer deep in Earth's oceans. The pressure alone would crush an unprotected human almost instantly. But the atmosphere is not the worst part. It gets much, much worse. That thick carbon dioxide atmosphere creates the most extreme greenhouse effect in our solar system. The carbon dioxide traps heat from the sun with terrifying efficiency, raising the surface temperature of Venus to an average of about 465 degrees Celsius. That is hot enough to melt lead, and it makes Venus the hottest planet in our solar system, even hotter than Mercury, despite being nearly twice as far from the sun. Day or night, it does not matter. The thick atmosphere distributes heat so efficiently that the temperature barely changes whether you're in direct sunlight or on the dark side of the planet. Venus is basically a pressure cooker cranked up to maximum. And if the crushing pressure and scorching temperature were not enough, the clouds of Venus are made of sulfuric acid. Yes, you read that right, sulfuric acid. These thick clouds completely blanket the planet, hiding the surface from view and giving Venus its bright yellowish-white appearance when seen from Earth. If you somehow survived the pressure and the heat and tried to float up into the clouds, you would be dissolved by acid rain. Venus really does not want visitors. Venus also has some bizarre rotation characteristics that set it apart from most other planets. First, Venus rotates backwards compared to most planets. While Earth and most other planets spin counterclockwise when viewed from above their north poles, Venus spins clockwise. This is called retrograde rotation, and Venus shares this quirk with only Uranus among the planets. Scientists are not entirely sure why Venus rotates backwards, but the leading theory involves a massive collision early in the planet's history that flipped its rotation, or slowed it down and reversed it over time. Speaking of slow, Venus is the slowest rotating planet in our solar system. It takes 243 Earth days for Venus to complete one rotation on its axis. But here's another mind-bending fact. Venus orbits the Sun faster than it rotates. One Venus year, the time it takes to complete one orbit around the Sun, is only 225 Earth days. So a day on Venus, from sunrise to sunrise, is actually longer than its year. If you lived on Venus, your birthday would come before you even finished one day. The planet would complete its entire journey around the Sun while it was still the same Venusian day. Despite all these hostile conditions, Venus has fascinated humanity for millennia. It is the brightest natural object in our night sky after the moon, and ancient civilizations noticed this brilliant wandering star long before they understood what it really was. The Romans named it after their goddess of love and beauty, which is somewhat ironic given what we now know about conditions on its surface. Venus is visible from Earth as either the evening star, appearing in the western sky after sunset, or the morning star, appearing in the eastern sky before sunrise. It never strays far from the Sun in our sky because its orbit is inside Earth's orbit. The Soviet Union actually managed to land several spacecraft on Venus in the 1970s and 80s as part of their Venera program. These were the first spacecraft to successfully land on another planet and transmit data back to Earth. But the conditions on Venus were so extreme that even these heavily armored probes only survived for a couple of hours at most before the heat, pressure, and corrosive atmosphere destroyed them. The images they sent back revealed a barren, rocky landscape bathed in an eerie orange glow from the thick clouds above, with flat stones scattered across the surface. Scientists believe that Venus may have once been much more Earth-like. Billions of years ago, it may have had liquid water on its surface and a much more hospitable climate. But as the Sun gradually grew brighter over time, Venus experienced a runaway greenhouse effect. The oceans evaporated, the water vapor added to the greenhouse effect, temperatures rose further, more water evaporated, and the cycle continued until Venus became the hellish world we see today. This is actually a sobering reminder for us here on Earth about the potential consequences of unchecked greenhouse gas emissions. Beneath its toxic clouds, Venus has a surface shaped by volcanic activity. It has more volcanoes than any other planet in our solar system, with over 1,600 major volcanoes and countless smaller ones. Some scientists believe that Venus may still be volcanically active today, though we have not yet confirmed this directly. The planet also lacks plate tectonics like Earth has, which means heat from the interior builds up over long periods and may be released through massive planet-wide volcanic events. Now, I know we have been talking about some pretty harsh and alien environments so far. Mercury with its cratered surface and extreme temperature swings, Venus with its crushing pressure and hellish temperatures. But our next destination is one that should feel a little more familiar. In fact, it is the only place in the entire universe where we know for certain that life exists. We are coming home. Let us talk about Earth. Earth is the third planet from the Sun, orbiting at an average distance of about 150 million kilometers, or roughly 93 million miles. This distance is so important in astronomy that scientists actually use it as a standard unit of measurement called the astronomical unit, or AU. When you hear astronomers talk about distances in the solar system in astronomical units, they are measuring relative to Earth's distance from the Sun. So Earth is, by definition, 1 AU from the Sun. Mercury is about 0.39 AU, Venus is about 0.72 AU, and so on outward through the solar system. Earth is the largest of the 4 terrestrial planets with a diameter of about 12,756 kilometers. It is also the densest planet in the entire solar system. This high density comes from Earth's composition, particularly its large iron-nickel core. The core alone is nearly the size of Mars, and it is responsible for generating Earth's magnetic field, which plays a crucial role in making our planet habitable. What makes Earth truly special, what sets it apart from every other world we have visited so far and every other world we will visit in this video, is water. Earth is the only planet in our solar system with liquid water on its surface, and not just a little bit of water. About 71% of Earth's surface is covered by oceans. This liquid water is absolutely essential for life as we know it, and it exists on Earth because of our planet's perfect position in what scientists call the habitable zone, sometimes called the Goldilocks zone. We are not too close to the Sun, like Mercury and Venus, where water would boil away, and we are not too far from the Sun, where water would freeze solid. Earth is just right. But distance from the Sun is not the only factor. Our atmosphere plays a huge role too. Our atmosphere is about 78% nitrogen, 21% oxygen, and small amounts of other gases, including water vapor, argon, and carbon dioxide. This atmosphere provides just enough greenhouse effect to keep our planet warm enough for liquid water, but not so much that we end up like Venus. The atmosphere also protects us from harmful solar radiation and cosmic rays, and it burns up most of the small meteors that would otherwise crash into the surface. Earth's magnetic field is another crucial factor in our planet's habitability. Generated by convection currents in the liquid outer core, this magnetic field extends far out into space, creating a protective bubble called the magnetosphere. The magnetosphere deflects the solar wind, a constant stream of charged particles flowing from the Sun. Without this magnetic shield, the solar wind would gradually strip away our atmosphere, much like what scientists believe happened to Mars billions of years ago. The magnetosphere also protects us from some of the harmful radiation that would otherwise make life on the surface very difficult. Earth has one natural satellite, our beloved Moon. At about 3,474 kilometers in diameter, the Moon is the 5th largest moon in the solar system. It is so large relative to Earth that some scientists consider the Earth-Moon system to be almost a double planet. The Moon has a profound effect on Earth. It stabilizes our planet's axial tilt, preventing wild swings in our seasons that could make the climate much more extreme. The Moon's gravity also causes the tides, the rhythmic rising and falling of ocean waters that has influenced the development of life on Earth in countless ways. What really makes Earth unique in our solar system is life. As far as we know, Earth is the only place where life has evolved. From the simplest single-celled organisms in the deep ocean vents to the complex ecosystems of rainforests, from the microscopic bacteria in the soil to the great whales cruising through the oceans, Earth teems with an incredible diversity of life. And among all these living things, We humans are the only species capable of looking up at the stars and wondering what is out there. We are the only species building telescopes and spacecraft to explore our cosmic neighborhood. That is pretty remarkable when you think about it. Earth is also the only planet in our solar system with active plate tectonics. The surface is divided into large tectonic plates that float on the semi-liquid mantle below. These plates move, collide, and separate over millions of years, creating mountains, earthquakes, volcanic activity, and constantly reshaping the surface. This geological activity is linked to the carbon cycle, which helps regulate our climate over very long timescales. Without plate tectonics, Earth might have ended up much more like Venus. Our planet orbits the Sun once every 365.25 days, which is why we have leap years every 4 years to keep our calendars aligned with the seasons. Earth rotates on its axis once every 24 hours, giving us our day and night cycle. The axis is tilted at about 23.5 degrees relative to our orbital plane, and this tilt is what creates our seasons. When the northern hemisphere is tilted toward the sun, it experiences summer while the southern hemisphere has winter. 6 months later, the situation is reversed. All right, I've spent a lot of time talking about our home planet, but that is because it really is special. Now it's time to venture further from the sun and visit a world that has captured human imagination for centuries. A rusty red planet that many believe could one day become humanity's second home. We're heading to Mars. Mars is the 4th planet from the Sun, orbiting at an average distance of about 228 million kilometers, or roughly 142 million miles. It's often called the red planet because of its distinctive rusty color, which comes from iron oxide, essentially rust, covering much of its surface. This color made Mars stand out to ancient observers who associated it with blood and warfare. The Romans named it after their god of war, and many other ancient cultures made similar associations. Mars is significantly smaller than Earth. With a diameter of about 6,792 kilometers, it's roughly half the size of Earth. Its mass is only about 10% of Earth's mass. This smaller size means Mars has weaker gravity. If you weighed 100 pounds on Earth, you would weigh only 38 pounds on Mars. You could jump 3 times higher and throw a ball 3 times farther with the same effort. Despite being smaller, Mars has some truly impressive geological features. The largest volcano in the entire solar system, Olympus Mons, rises from the Martian surface. This shield volcano is about 22 kilometers high, nearly 3 times the height of Mount Everest, and its base is so wide it would cover most of France. Olympus Mons is so enormous that if you stood at its base, you would not be able to see the top, because it would extend beyond the horizon due to the curvature of Mars. Mars also boasts the largest canyon system in the solar system. Valles Marineris stretches for about 4,000 kilometers across the Martian surface, roughly the distance from New York to Los Angeles. It's up to 7 kilometers deep in some places, making Earth's Grand Canyon look like a minor scratch in comparison. Valles Marineris is so long that if it were on Earth, it would stretch across the entire United States. One of the most exciting things about Mars is the evidence that liquid water once flowed on its surface. Today, Mars is cold and dry, with temperatures averaging around -60 degrees Celsius. Any water on the surface would freeze instantly. But billions of years ago, Mars was a very different world. Ancient river channels, lake beds, and even what appears to be an ancient ocean shoreline in the northern hemisphere all point to a wetter, warmer past. Scientists believe Mars once had a thicker atmosphere that created enough of a greenhouse effect to allow liquid water to exist. So what happened? Where did all that water go? The answer lies in Mars's lack of a global magnetic field. Unlike Earth, Mars does not have a liquid outer core generating a protective magnetic field. Billions of years ago, when Mars's core cooled and solidified, the magnetic field shut down. Without that protection, the solar wind gradually stripped away most of the Martian atmosphere. As the atmosphere thinned, the greenhouse effect weakened, temperatures dropped, and the surface water either froze into ice or escaped into space. Today, Mars has an atmosphere that is only about 1% as thick as Earth's. Despite the thin atmosphere, Mars still has weather. Dust storms can rage across the planet, sometimes growing so large they engulf the entire globe. These planet-wide dust storms can last for months and have actually caused problems for our Mars rovers, which rely on solar panels for power. When the sky fills with dust, less sunlight reaches the panels, and the rovers have to conserve energy until the storm passes. Mars has two small moons named Phobos and Deimos after the Greek gods of fear and terror, who accompanied Ares, the Greek god of war, into battle. These moons are tiny and irregular, more like captured asteroids than proper moons. Phobos is only about 22 kilometers across, and Deimos is even smaller at only about 12 kilometers. Phobos orbits so close to Mars and so fast that it actually rises in the west and sets in the east, appearing to move backward across the Martian sky. Scientists believe Phobos is slowly spiraling inward toward Mars and will eventually either crash into the planet or break apart into a ring system in about 50 million years. The day on Mars is remarkably similar to an Earth day. Mars rotates on its axis once every 24 hours and 37 minutes, so a Martian day, called a sol, is only about 40 minutes longer than an Earth day. This similarity has made it relatively easy for mission controllers on Earth to coordinate with rovers on Mars, though over time, the slight difference causes the Martian day to drift relative to Earth time. Mars takes 687 Earth days to orbit the Sun, so a Martian year is nearly twice as long as an Earth year. Because the orbits of Earth and Mars are different lengths and different shapes, the distance between our two planets varies dramatically. At closest approach, called opposition, Mars can be as close as about 55 million kilometers. At its farthest, when Mars is on the opposite side of the Sun from Earth, it can be over 400 million kilometers away. This is why space agencies time their Mars missions carefully. Launching during a close approach saves fuel and reduces travel time. Mars has been explored more than any other planet besides Earth. We have sent orbiters, landers, and rovers to study the red planet in incredible detail. Rovers like Curiosity and Perseverance have driven across the Martian surface, drilling into rocks, analyzing soil, and searching for signs of past or present life. So far, we have not found definitive evidence of life on Mars, but we have learned that Mars was once potentially habitable and may still harbor microbial life deep underground, where liquid water might exist. Many people believe Mars will be the next destination for human explorers. Space agencies and private companies are working on plans to send humans to Mars, possibly within the next couple of decades. The challenges are enormous. The journey would take about 7 months each way. Astronauts would have to survive on a hostile world with toxic soil and deadly radiation, and they would have to either bring everything they need from Earth or learn to live off the Martian land. But humans have always been explorers, and Mars represents the next great frontier. Now we have finished touring the inner solar system, the realm of rocky terrestrial planets. To continue our journey, we need to cross a vast gap in space. Between Mars and our next destination lies the asteroid belt, a region containing millions of rocky objects left over from the solar system's formation. Most asteroids are relatively small, but the largest object in the belt, Ceres, is big enough to be classified as a dwarf planet. The asteroid belt might sound dangerous, like something out of a science fiction movie where spaceships have to dodge rocks left and right, but in reality, the belt is mostly empty space. The average distance between asteroids is nearly 1 million kilometers, more than double the distance from Earth to the Moon. Spacecraft pass through the asteroid belt all the time without any problems. Beyond the asteroid belt, we enter a completely different part of our solar system, the realm of the giants. And the first giant we encounter is the king of all planets, a world so massive it could swallow all the other planets combined and still have room for more. We are heading to Jupiter. Jupiter is the 5th planet from the Sun, orbiting at an average distance of about 778 million kilometers, or roughly 484 million miles. That is about 5 times farther from the Sun than Earth. At this distance, Jupiter receives only about 4% as much solar energy as Earth does. But distance is far from the most remarkable thing about Jupiter. This planet is truly in a league of its own. Jupiter is absolutely enormous. With a diameter of about 143,000 kilometers, it is more than 11 times wider than Earth. You could line up over 11 Earths across Jupiter's equator. But the difference in volume is even more staggering. You could fit about 1,300 Earths inside Jupiter. Let that sink in for a moment. 1,300 Earths. If Earth were a basketball, Jupiter would be a large beach ball. Despite its enormous size, Jupiter is not a rocky world like the planets we have visited so far. Jupiter is a gas giant, meaning it is composed primarily of hydrogen and helium, the same elements that make up the Sun. In fact, Jupiter has often been called a failed star. If it had been about 80 times more massive, the pressure and temperature at its core would have been high enough to ignite nuclear fusion, and Jupiter would have become a star, making our solar system a binary star system. But Jupiter fell far short of that threshold, so it remains a planet, albeit the most massive one in our solar system. Jupiter has no solid surface in the traditional sense. If you tried to land a spacecraft on Jupiter, you would simply sink deeper and deeper into an increasingly dense atmosphere. The visible surface we see in images is actually just the top of Jupiter's cloud layers. These clouds are arranged in distinct bands that wrap around the planet, driven by powerful jet streams and storms. The lighter bands are called zones, where gas is rising, and the darker bands are called belts, where gas is sinking. The most famous feature on Jupiter is the Great Red Spot, a massive storm that has been raging for at least 350 years, since humans first observed it through telescopes. The Great Red Spot is so large that Earth could fit inside it with room to spare. At its peak, it was about 3 times the size of Earth, though it has been shrinking over the past century and is now only about 1 1/3 times Earth's diameter. Despite this shrinkage, the Great Red Spot remains the largest storm in the solar system, with wind speeds reaching up to 640 kilometers per hour. Jupiter rotates incredibly fast for a planet of its size. It completes one rotation in just under 10 hours, making it the fastest rotating planet in the solar system. This rapid rotation causes Jupiter to bulge noticeably at its equator. The planet's equatorial diameter is about 9,000 kilometers larger than its polar diameter. The fast rotation also drives the powerful jet streams that create Jupiter's banded appearance. Jupiter has an incredibly powerful magnetic field about 20,000 times stronger than Earth's. This magnetic field traps charged particles from the solar wind, creating intense radiation belts around the planet. These radiation belts are so intense that they would be lethal to unprotected humans and can damage spacecraft electronics. Any crewed mission to Jupiter's vicinity would need serious radiation shielding. One of the most fascinating aspects of Jupiter is its extensive moon system. As of the most recent counts, Jupiter has over 90 known moons, more than any other planet in our solar system except Saturn. The 4 largest moons, discovered by Galileo Galilei in 1610, are known as the Galilean moons. They are Io, Europa, Ganymede, and Callisto, and each one is a fascinating world in its own right. Io is the innermost of the Galilean moons and the most volcanically active body in the entire solar system. Jupiter's immense gravity creates tidal forces that flex and squeeze Io, generating internal heat that drives constant volcanic eruptions. The surface of Io is covered with sulfur and sulfur dioxide, giving it a yellowish, pizza-like appearance. Volcanic plumes regularly shoot material hundreds of kilometers into space. Europa is perhaps the most exciting moon in the solar system from an astrobiological perspective. It has a smooth, icy surface with very few impact craters, suggesting the surface is young and constantly being renewed. Beneath this icy shell, scientists believe there is a global ocean of liquid water, kept liquid by tidal heating similar to what creates Io's volcanism. This subsurface ocean may contain more water than all of Earth's oceans combined. Where there is liquid water, there might be life, making Europa one of the top targets in the search for extraterrestrial life. Ganymede is the largest moon in the entire solar system, even larger than the planet Mercury. It is the only moon known to have its own magnetic field, suggesting it has a liquid iron core similar to Earth's. Ganymede also likely has a subsurface ocean beneath its icy crust. Callisto is the most heavily cratered object in the solar system. Its surface has remained largely unchanged for billions of years, providing a record of the early solar system's impact history. Callisto may also have a subsurface ocean, though it is less certain than Europa or Ganymede. Jupiter plays a crucial role in the dynamics of our solar system. Its immense gravity has influenced the orbits of other planets and the distribution of material in the asteroid belt. Some scientists believe Jupiter acts as a partial shield for the inner solar system, deflecting or capturing comets and asteroids that might otherwise strike Earth. However, other research suggests Jupiter might actually send some objects toward the inner solar system that would otherwise have stayed in the outer solar system. Either way, Jupiter's gravitational influence has shaped our solar system in profound ways. Jupiter takes about 12 Earth years to complete one orbit around the Sun. From Earth, it appears as one of the brightest objects in the night sky, usually outshone only by the Moon and Venus. Through even a small telescope, you can see Jupiter's cloud bands and the 4 Galilean moons as tiny dots lined up on either side of the planet. Now let us continue our journey outward, leaving Jupiter and its many moons behind. Our next destination is a world that has captivated human imagination, perhaps more than any other planet in our solar system. A world famous for its stunning, iconic feature that sets it apart from every other body in the cosmos. We are heading to Saturn. Saturn is the 6th planet from the Sun, orbiting at an average distance of about 1.4 billion kilometers, or roughly 889 million miles. That's about 9.5 times farther from the Sun than Earth. At this distance, Saturn receives only about 1% as much solar energy as Earth. It takes nearly 30 Earth years for Saturn to complete one orbit around the Sun. If you were born on Earth when Saturn was at a particular position, you would have to wait until you were almost 30 years old to see Saturn return to that same position. Saturn is the 2nd largest planet in our solar system, with a diameter of about 120,500 kilometers. While it is not quite as large as Jupiter, Saturn is still enormous. You could fit about 700 Earths inside Saturn. Like Jupiter, Saturn is a gas giant, composed primarily of hydrogen and helium. And, like Jupiter, Saturn has no solid surface. The visible disk we see is just the top of its cloud layers. But the most striking feature of Saturn, the feature that makes it instantly recognizable and arguably the most beautiful planet in our solar system, is its magnificent ring system. Saturn's rings are absolutely breathtaking. When Galileo first observed Saturn through his primitive telescope in 1610, he was confused by what he saw. He described the planet as having ears or handles. It was not until later observations with better telescopes that astronomers realized they were seeing a ring system surrounding the planet. Saturn's rings are composed primarily of water ice, with smaller amounts of rocky debris and dust. The particles in the rings range in size from tiny grains smaller than a grain of sand to massive chunks the size of houses or even mountains. The main rings extend from about 6,600 kilometers above Saturn's cloud tops out to about 120,700 kilometers. That means the ring system would span most of the distance from Earth to the Moon. Yet despite this enormous extent, the rings are incredibly thin. In most places, the rings are only about 10 to 20 meters thick. If you built a scale model with the rings being the size of a football field, they would be thinner than a sheet of paper. Scientists are not entirely certain how Saturn's rings formed. They may be the remnants of a comet, asteroid, or moon that wandered too close to Saturn and was torn apart by tidal forces. Or they may be material left over from the formation of Saturn itself that never coalesced into a moon. Recent data from the Cassini spacecraft suggests the rings may be relatively young in geological terms, perhaps only 100 million years old, which means dinosaurs may have roamed Earth before Saturn had its famous rings. The rings may also be temporary, slowly raining material down onto Saturn and potentially disappearing in another 100 million years or so. Saturn has several distinct ring structures, labeled with letters in the order they were discovered. The main rings, from innermost to outermost, are the D, C, B, A, F, G, and E rings. The A and B rings are the brightest and most visible, separated by a gap called the Cassini division that is about 4,800 kilometers wide. The rings have complex structures, including waves, gaps, and features caused by gravitational interactions with Saturn's many moons. Speaking of moons, Saturn is the undisputed king of moons in our solar system. As of the most recent count, Saturn has 146 confirmed moons, more than any other planet. Many of these are small, irregular moons, likely captured from the asteroid belt or Kuiper belt. But Saturn also has some truly remarkable larger moons. Titan is Saturn's largest moon and the second largest moon in the entire solar system after Jupiter's Ganymede. Titan is actually larger than the planet Mercury. What makes Titan truly unique is its thick atmosphere, the only moon in the solar system with a substantial atmosphere. Titan's atmosphere is even denser than Earth's, with surface pressure about 50% higher than on Earth. The atmosphere is primarily nitrogen, like Earth's, but instead of oxygen, the remaining percentage is methane and other organic compounds. The surface of Titan is obscured by orange haze, but radar imaging from the Cassini spacecraft revealed an incredible landscape. Titan has lakes and seas of liquid methane and ethane. It has rivers that carve channels through the terrain. It has rain that falls from clouds. Titan has a weather cycle similar to Earth's water cycle, but with hydrocarbons instead of water. In many ways, Titan is one of the most Earth-like worlds in our solar system, despite being so different in its specific chemistry. Some scientists speculate that life could potentially exist on Titan, though it would have to be very different from life on Earth. Enceladus is another fascinating moon of Saturn. It is much smaller than Titan, only about 500 kilometers across, but it has revealed an exciting secret. The Cassini spacecraft discovered plumes of water vapor and ice particles erupting from cracks near Enceladus's south pole. These geysers spray material hundreds of kilometers into space, and much of it falls back to feed Saturn's E-ring. The geysers indicate that Enceladus has a subsurface ocean of liquid water beneath its icy crust, kept liquid by tidal heating. Analysis of the plume material has found organic compounds and molecular hydrogen, suggesting hydrothermal activity at the ocean floor. Like Europa around Jupiter, Enceladus is considered a prime target in the search for extraterrestrial life. Saturn itself has a banded appearance similar to Jupiter, though the bands are more muted and less distinct because Saturn's atmosphere is hazier. Saturn's atmosphere is about 96% hydrogen by volume, making it even more hydrogen-rich than Jupiter. In fact, Saturn is so low in density that if you could find a bathtub big enough, the entire planet would float in water. It is the least dense planet in our solar system, less dense than water. Saturn also has a hexagonal storm at its north pole that is one of the most bizarre features in the solar system. This hexagon is about 30,000 kilometers across, large enough to fit nearly 4 Earths inside. Each side of the hexagon is longer than Earth's diameter. Scientists believe the hexagon is created by differences in wind speeds at different latitudes, creating a standing wave pattern, but the exact mechanism is still not fully understood. Saturn rotates in about 10.5 hours, second only to Jupiter among the planets. This rapid rotation, combined with Saturn's low density, gives it the most pronounced equatorial bulge of any planet. Saturn's equatorial diameter is about 12,000 kilometers larger than its polar diameter. Through a telescope from Earth, Saturn is one of the most rewarding sights in the night sky. Even a small telescope reveals the rings, though you need moderate magnification to see them clearly. The sight of Saturn floating in the eyepiece, surrounded by its delicate rings, is an experience that has inspired countless people to take up astronomy. Many astronomers consider their first view of Saturn through a telescope to be a defining moment that sparked their passion for exploring the cosmos. Now we continue our journey into the outer reaches of the solar system, venturing into even colder and more distant realms. The next two planets are often grouped together as the ice giants, distinct from the gas giants Jupiter and Saturn. These worlds are smaller and have different compositions, with more water, ammonia, and methane ices in their makeup. Our next stop is the first of these ice giants, a planet that rotates on its side and is full of mysteries. We are heading to Uranus. Uranus is the seventh planet from the Sun, orbiting at an average distance of about 2.9 billion kilometers, or roughly 1.8 billion miles. That is about 19 times farther from the Sun than Earth. At this incredible distance, sunlight takes about 2 hours and 40 minutes to reach Uranus, compared to just over 8 minutes to reach Earth. Uranus receives only about 1/400th as much solar energy as Earth. Uranus was the first planet discovered in modern times using a telescope. All the planets from Mercury through Saturn were known to ancient people because they are visible to the naked eye. But Uranus is too dim to be easily spotted without optical aid. It was discovered in 1781 by the astronomer William Herschel, who initially thought it might be a comet. Further observations confirmed it was a new planet, doubling the known size of the solar system overnight. With a diameter of about 51,118 kilometers, Uranus is about 4 times wider than Earth and is the third largest planet in our solar system. Despite being larger in diameter than Neptune, Uranus is actually less massive. Neptune contains about 17% more mass than Uranus, despite being slightly smaller. This difference is due to Neptune having a higher proportion of heavy elements in its interior. The most striking thing about Uranus is its extreme axial tilt. While most planets spin with their axes roughly perpendicular to their orbital planes, Uranus is tipped over on its side, with an axial tilt of about 98 degrees. This means Uranus essentially rolls around the Sun like a ball, with its poles taking turns pointing almost directly at the Sun. During the Uranian summer at one pole, that pole experiences about 42 Earth years of continuous sunlight, while the other pole is in darkness. Then the situation reverses for the next Uranian summer. Scientists are not certain why Uranus is tilted so dramatically. The leading theory is that a massive collision with an Earth-sized object early in the solar system's history knocked Uranus onto its side. This collision may also explain some of the unique characteristics of Uranus's moons and rings. Uranus has a distinctive blue-green color that comes from methane in its atmosphere. The atmosphere is primarily hydrogen and helium, but contains more methane than Jupiter or Saturn. Methane absorbs red light and reflects blue and green wavelengths, giving Uranus its characteristic hue. Beneath the visible clouds, Uranus has an icy mantle of water, methane, and ammonia surrounding a small rocky core. Unlike Jupiter and Saturn with their dramatic storms and bands, Uranus appears remarkably featureless when viewed in visible light. The Voyager 2 spacecraft, which remains the only probe to visit Uranus, found a surprisingly calm atmosphere during its flyby in 1986. However, more recent observations with powerful telescopes have revealed that Uranus does have storms and cloud features, just much more subtle than the other giant planets. One of the great mysteries about Uranus is its internal heat. Jupiter, Saturn, and Neptune all radiate significantly more heat into space than they receive from the Sun, due to heat left over from their formations still slowly escaping. But Uranus barely radiates any excess heat at all. Its internal temperature is colder than the other giant planets, and scientists are not sure why. The giant impact that tipped Uranus on its side may have somehow allowed the planet to cool more efficiently. Or there may be a layer in Uranus's interior that prevents heat from escaping. Uranus has a ring system, though nothing as spectacular as Saturn's. The rings of Uranus were not discovered until 1977, when astronomers observed a star passing behind Uranus and noticed the starlight blink on and off multiple times before and after being blocked by the planet itself. This indicated that rings were blocking the starlight. Uranus has 13 known rings, composed of dark particles that do not reflect light well, which is why they are so difficult to see. Uranus has 27 known moons, all named after characters from the works of William Shakespeare and Alexander Pope. The 5 largest moons are Miranda, Ariel, Umbriel, Titania, and Oberon. Miranda is particularly interesting because its surface shows dramatic geological features, including enormous cliffs and strange grooved terrain, suggesting a violent history. Some scientists have proposed that Miranda was once shattered by an impact and then reassembled from the fragments. Very recently, in 2025, astronomers using the James Webb Space Telescope discovered a previously unknown 28th moon of Uranus, provisionally named S2025U1. This discovery shows that even in our own solar system, there are still new worlds waiting to be found. Uranus takes about 84 Earth years to complete one orbit around the Sun. This means that since its discovery in 1781, Uranus has completed only about 3 orbits. A single Uranian year is longer than a human lifetime. The planet rotates on its tilted axis about once every 17 hours. From Earth, Uranus is just barely visible to the naked eye under perfect dark sky conditions, but you would need to know exactly where to look. Through a telescope, it appears as a small, featureless blue-green disk. Unlike the spectacular views of Jupiter and Saturn, Uranus requires patience and imagination to appreciate. Now we come to the final planet in our grand tour of the solar system, the most distant planet. A world so far away that it was discovered not by observation, but by mathematics. Astronomers noticed that Uranus was not quite following the path predicted by gravitational calculations. Something was tugging on it, something massive and unseen. In 1846, using the mathematics of gravity, astronomers predicted where this mysterious object should be, pointed their telescopes at that spot, and found a new planet. We are heading to Neptune. Neptune is the 8th and most distant planet in our solar system, orbiting at an average distance of about 4.5 billion kilometers, or roughly 2.8 billion miles. That is about 30 times farther from the Sun than Earth. Light from the Sun takes over 4 hours to reach Neptune. At this extreme distance, Neptune receives only about 1/900th as much solar energy as Earth. Neptune is slightly smaller than Uranus in diameter, measuring about 49,528 kilometers across. However, as mentioned earlier, Neptune is actually more massive than Uranus, containing about 17% more mass. This makes Neptune the densest of the giant planets. The extra mass comes from a higher proportion of heavier elements in Neptune's interior. Like Uranus, Neptune has a beautiful blue color, though Neptune's blue is deeper and more intense. This color also comes from methane in the atmosphere absorbing red light, but Neptune's atmosphere has additional unknown compounds that contribute to its richer blue hue. Neptune is sometimes called the blue giant to distinguish it from Uranus's greener tint. Unlike the calm and featureless Uranus, Neptune has active and dramatic weather. The Voyager 2 spacecraft discovered the Great Dark Spot during its flyby in 1989, a massive storm similar to Jupiter's Great Red Spot. The great dark spot was about the size of Earth and was accompanied by bright white clouds of methane ice crystals, nicknamed Scooter and Dark Spot 2. However, when the Hubble Space Telescope observed Neptune a few years later, the great dark spot had vanished. New storms have since appeared and disappeared, showing that Neptune's atmosphere is dynamic and constantly changing. Neptune has the strongest winds of any planet in the solar system. Wind speeds on Neptune can reach up to 2,100 kilometers per hour. That is faster than the speed of sound and several times faster than the most powerful hurricanes on Earth. Scientists are puzzled by how Neptune generates such powerful winds when it receives so little energy from the sun. The answer may lie in Neptune's internal heat. Unlike Uranus, Neptune radiates significantly more energy into space than it receives from the sun, about 2.5 times more. This internal heat drives convection in the atmosphere and powers the violent weather. Neptune has a faint ring system similar to Uranus's, composed of dark particles. The rings include features called arcs, where the ring material is clumped together in certain locations rather than being evenly distributed. Scientists believe tiny moons help confine the ring material into these arc structures. Neptune has 16 confirmed moons as of 2025. By far the largest and most interesting is Triton, which contains more than 99% of all the mass orbiting Neptune. Triton is the 7th largest moon in the solar system and is larger than the dwarf planet Pluto. It has a retrograde orbit, meaning it orbits Neptune in the opposite direction from Neptune's rotation. This strongly suggests that Triton was not formed alongside Neptune, but was instead captured from the Kuiper belt, possibly after a collision slowed it down enough to be gravitationally captured. Triton has a thin atmosphere of nitrogen and is one of the coldest objects in the solar system, with surface temperatures around -235 degrees Celsius. Despite this extreme cold, Triton is geologically active. Voyager 2 observed geysers on Triton, shooting plumes of nitrogen gas and dark particles up to 8 kilometers into the sky. This makes Triton one of only 3 moons in the solar system known to be geologically active, along with Io and Enceladus. Because of its retrograde orbit, Triton is slowly spiraling inward toward Neptune. In roughly 3.5 billion years, Triton will either collide with Neptune or be torn apart by tidal forces to form a spectacular ring system. Either way, Neptune's future holds dramatic changes. Neptune takes about 165 Earth years to complete one orbit around the Sun. Since its discovery in 1846, Neptune has completed only one full orbit, returning to the position where it was discovered in 2011. A single year on Neptune is longer than the entire history of human flight, computers, and modern medicine combined. Neptune rotates on its axis once every 16 hours, making its days shorter than Earth's. Unlike Uranus, Neptune has a fairly typical axial tilt of about 28 degrees, similar to Earth's, so it experiences seasons, though each season lasts over 40 Earth years. From Earth, Neptune is never visible to the naked eye. Even through a telescope, it appears as a tiny blue dot with no discernible features unless you have professional-grade equipment. The Voyager 2 flyby in 1989 remains the only close-up visit to Neptune, and scientists are eager for future missions to explore this distant world in more detail. And there you have it, my friends. We have traveled from the sun-scorched surface of Mercury to the frozen reaches of Neptune. We have visited worlds of fire and worlds of ice, rocky planets and gas giants, worlds with thick, crushing atmospheres and worlds with almost no atmosphere at all. We have seen massive storms, spectacular rings, volcanic moons, and subsurface oceans that might harbor life. But our solar system contains more than just these 8 planets. Beyond Neptune lies the Kuiper belt, a vast region of icy objects left over from the solar system's formation. This is where we find the dwarf planets, including the most famous one of all, Pluto. In 2006, astronomers reclassified Pluto from a planet to a dwarf planet because it has not cleared its orbital neighborhood of other debris. This decision was controversial and still sparks debate today. But whether we call it a planet or a dwarf planet, Pluto remains a fascinating world. The New Horizons spacecraft flew past Pluto in 2015 and revealed a surprisingly complex world with mountains of water ice, glaciers of frozen nitrogen, and a heart-shaped feature now officially named Tombaugh Regio after Pluto's discoverer. Other dwarf planets in our solar system include Ceres in the asteroid belt, Eris in the scattered disk beyond Pluto, Haumea with its egg-like shape and ring system, and Makemake with its reddish color. And there are likely many more dwarf planets waiting to be discovered in the outer reaches in our solar system. When you think about everything we have covered today, it is truly humbling. Our solar system is vast beyond imagination. Light, the fastest thing in the universe, takes over 4 hours to travel from the Sun to Neptune. A spacecraft traveling at human-achievable speeds takes years to reach the outer planets. And yet our entire solar system is just a tiny speck in the Milky Way galaxy, which itself is just one of hundreds of billions of galaxies in the observable universe. But here is what I find most inspiring. We, tiny humans on a small rocky planet orbiting an ordinary star, have managed to explore all of this. We have sent robots to every planet in our solar system. We have landed on Mars and Venus. We have flown through the atmospheres of Jupiter and Saturn. We have visited comets and asteroids. We have even sent spacecraft beyond the boundary of our solar system into interstellar space. Human curiosity and ingenuity are truly remarkable. And we're just getting started. In the coming decades, we will likely see humans walk on Mars. We will send probes to explore the oceans of Europa and Enceladus. We will learn more about the mysteries of Uranus and Neptune. Every day, astronomers are discovering new things about our cosmic neighborhood. So the next time you look up at the night sky, take a moment to think about the incredible worlds hanging out there in the darkness. That bright dot might be Venus, our hellish twin wrapped in acid clouds. That reddish point might be Mars, where robots are right now searching for signs of life. That brilliant beacon might be Jupiter, king of the planets, with its dozens of moons. Each of those points of light is a world, and each world has its own story to tell. Well, my fellow space travelers, we have come to the end of our journey today. We started at Mercury, just 58 million kilometers from the Sun, and traveled all the way to Neptune, 4.5 billion kilometers away. We covered billions of miles without ever leaving your screen. How amazing is that? I really hope you enjoyed this cosmic adventure as much as I enjoyed taking you on it. If you learned something new today, and I am betting you did, please give this video a big thumbs up. That like button really does make a difference in helping other space enthusiasts find this content. And if you are not already subscribed to the channel, what are you waiting for? Hit that subscribe button and join our community of cosmic explorers. We have so many more adventures ahead of us. Do not forget to share this video with someone you think would enjoy it. Maybe a friend who loves space, a family member who is curious about the planets, or a kid who dreams of being an astronaut someday. Knowledge is meant to be shared, and nothing brings me more joy than knowing this video helped someone fall in love with the wonders of our universe. One more time, drop a comment below telling me where you are watching from and what time it is there. I absolutely love reading your comments and connecting with viewers from all over the world. Every comment is a reminder that our love of space exploration truly spans the entire globe. It is beautiful to see people from different countries, different cultures, and different time zones all coming together to learn about the universe we share. Thank you so much for spending this time with me today. Whether you are watching this in the morning with your coffee, during your lunch break, or late at night when you should probably be sleeping, I appreciate every single one of you. Your views, your likes, your comments, and your subscriptions make this channel possible. Until next time, keep looking up at the stars, keep asking questions, keep exploring, and keep wondering about the incredible universe we live in. Goodbye for now, and good night to all of you watching in the evening hours. Sweet dreams, and may your dreams be filled with the wonders of the cosmos. Take care, stay curious, and I will see you in the next video.